If a pump is wired in reverse causing it to run backward, the amp draw will be higher. This occurs because the pump is working against its intended design and hydraulic forces. The motor struggles to move fluid in the opposite direction, leading to increased current flow. In a properly wired pump, the impeller or pumping mechanism is designed to efficiently move fluid in one direction. When the wiring is reversed, the impeller is effectively pushing against the fluid rather than with it. This creates additional resistance and requires the motor to work harder to achieve any fluid movement at all. The increased workload translates directly into a higher amp draw. To understand this better, consider the basic principles of motor operation. A motor converts electrical energy into mechanical energy to drive the pump. The amount of electrical energy measured in amps that the motor consumes is directly proportional to the mechanical load it's subjected to. A higher load means more work, thus a higher amp draw. When a pump is wired backward, the load increases significantly. This is because the impeller is not only trying to move fluid, but it's also fighting against the natural flow patterns and potentially creating turbulence and cavitation within the pump housing. Cavitation is the formation of vapor bubbles in a liquid, which can occur when the pressure drops rapidly. These bubbles collapse violently, creating noise, vibration, and damage to the pump components. This further increases the load on the motor. In a 3-wire connection, typically, there are 2 hot wires and a neutral wire, along with the ground. Reversing the hot wires can cause a single-phase motor to run in reverse. The ground wire is a safety measure, providing a path for fault current to flow back to the source in the event of a short circuit, thereby tripping a breaker or fuse and preventing electrical shock. When a pump is miswired, it's crucial to correct the wiring immediately. Operating a pump in reverse for an extended period can lead to several problems. Firstly, overheating of the motor. The increased amp draw generates more heat within the motor windings. If the motor is not properly cooled, this heat can damage the insulation on the windings, leading to short circuits and eventual motor failure. Secondly, damage to the pump components. The reverse operation can cause excessive wear and tear on the impeller, seals, and bearings. The turbulent flow and cavitation can erode the impeller and damage the sealing surfaces, leading to leaks and reduced pump efficiency. Thirdly, reduced pump performance. Even if the pump doesn't fail immediately, its performance will be significantly reduced. It will not be able to deliver the intended flow rate or pressure, which can disrupt the overall system it's designed to serve. Fourthly, increased energy consumption. The higher amp draw means that the pump is consuming more electricity than necessary, leading to higher energy bills. Over time, this can add up to a significant cost. Fifthly, potential safety hazards. If the motor overheats and the insulation fails, it can create a fire hazard or pose a risk of electrical shock to anyone who comes into contact with the pump. To prevent these problems, it's essential to ensure that the pump is wired correctly. Always follow the manufacturer's instructions and wiring diagram. If you're not comfortable working with electrical wiring, it's best to hire a qualified electrician to do the job. Before making any electrical connections, always disconnect the power to the circuit. This will prevent accidental electrical shock. Use a voltage tester to verify that the circuit is de-energized before touching any wires. When connecting the wires, make sure that they are properly insulated and securely connected. Loose connections can cause arcing, which can generate heat and create a fire hazard. Also, ensure that the ground wire is properly connected. The ground wire provides a path for fault current to flow back to the source in the event of a short circuit, thereby tripping a breaker or fuse and preventing electrical shock. If you suspect that a pump is wired backward, immediately disconnect the power and check the wiring. Use a multimeter to verify the correct voltage and polarity. If the wiring is incorrect, correct it immediately. After correcting the wiring, test the pump to ensure that it's operating properly. Check the amp draw with an amp meter to ensure that it's within the manufacturer's specification. If the amp draw is still high, there may be another problem with the pump, such as a damaged impeller or a clogged inlet. Also, consider the type of pump and its application. Centrifugal pumps, for example, are particularly sensitive to reverse rotation. These pumps rely on the impeller-specific design to efficiently move fluid outwards from the center. Running them in reverse drastically reduces the efficiency and increases the load on the motor. Positive displacement pumps, on the other hand, may be more tolerant of reverse rotation, but they can still experience increased amp draw and potential damage if run backward for an extended period. Furthermore, the fluid being pumped can also affect the amp draw. Viscous fluids require more power to pump than less viscous fluids. If the pump is being used to pump a viscous fluid, the amp draw will be higher than if it were pumping water. The design of the pump itself can also influence the impact of reverse wiring. Some pumps are designed with features that mitigate the effects of reverse rotation, such as non-return valves or impellers that are less sensitive to the direction of rotation. However, these features are not always present, and it's still important to ensure that the pump is wired correctly. In summary, running a pump in reverse due to incorrect wiring will result in a higher amp draw. This can lead to motor overheating, damage to pump components, reduced pump performance, increased energy consumption, and potential safety hazards. It's crucial to ensure that the pump is wired correctly and to correct any miswiring immediately. Always follow the manufacturer's instructions and wiring diagrams, and if you're not comfortable working with electrical wiring, hire a qualified electrician. Remember to always disconnect the power before working on any electrical equipment and use a voltage tester to verify that the circuit is energized. Proper wiring is essential for ensuring the safe and efficient operation of any pump system. Neglecting this aspect can lead to costly repairs, downtime, and potential safety risks. Therefore, it's important to pay close attention to the wiring and to follow all applicable electrical codes and safety regulations. In addition to the electrical considerations, it's also important to consider the mechanical aspects of the pump system. Ensure that the pump is properly mounted and aligned, and that all connections are tight and secure. Loose connections can cause vibration, which can damage the pump and reduce its lifespan. Also, ensure that the pump is properly lubricated. Proper lubrication reduces friction and wear, which can extend the life of the pump. Follow the manufacturer's recommendations for lubrication type and frequency. Regular maintenance is also essential for ensuring the long-term performance of the pump system. Inspect the pump regularly for signs of wear and tear, and replace any worn or damaged parts. Clean the pump regularly to remove any dirt or debris that may accumulate. Also, monitor the pump's performance and take corrective action if any problems are detected. By following these guidelines, you can ensure that your pump system operates safely and efficiently for many years to come. In the context of electrical systems and wiring, it's important to understand the fundamental principles of electricity. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. It represents the force that drives the flow of electric current. Amperage, or current, is the rate of flow of electric charge measured in amps. It represents the amount of electricity flowing through a circuit. Resistance is the opposition to the flow of electric current measured in ohms. It determines how much current will flow for a given voltage. These three quantities are related by Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. This relationship is fundamental to understanding how electrical circuits work. When a pump is wired in reverse, the resistance to the motor's rotation increases, which leads to a higher amp draw for a given voltage. The motor needs to work harder to overcome the increased resistance, and this requires more electrical current. In addition to Ohm's law, it's also important to understand the concept of power in electrical circuits. Power is the rate at which electrical energy is converted into other forms of energy, such as mechanical energy or heat. It's measured in watts, and it's equal to voltage times current, or watts equals volts times amps. When a pump is wired in reverse and the amp draw increases, the power consumption also increases. This means that the pump is using more electricity than it would if it were wired correctly. This can lead to higher energy bills and increased operating costs. Therefore, it's important to ensure that the pump is wired correctly to minimize power consumption and operating costs. Furthermore, it's essential to understand the different types of electrical circuits. There are two main types of circuits: series circuits and parallel circuits. In a series circuit, the components are connected in a single path, so the current flows through each component in turn. In a parallel circuit, the components are connected in multiple paths, so the current can flow through each component independently. The type of circuit can affect the amp draw and the overall performance of the electrical system. In the case of a pump, it's typically connected in a parallel circuit so that it can operate independently of other electrical loads. However, it's important to ensure that the circuit is properly sized to handle the pump's amp draw. If the circuit is too small, it can overload and trip the breaker or fuse. In addition to the electrical considerations, it's also important to consider the safety aspects of electrical systems. Electrical systems can be dangerous if not properly installed and maintained. It's important to follow all applicable electrical codes and safety regulations to prevent electrical shock, fire, and other hazards. Always disconnect the power before working on any electrical equipment, and use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, such as gloves and safety glasses, when working with electrical systems. Never work on electrical systems in wet or damp conditions. If you're not comfortable working with electrical systems, hire a qualified electrician to do the job. In conclusion, understanding the electrical principles and safety practices is essential for ensuring the safe and efficient operation of pump systems. Proper wiring, circuit sizing, and safety precautions are crucial for preventing electrical hazards and minimizing operating costs. By following these guidelines, you can ensure that your pump system operates reliably and safely for many years to come. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical systems. Their expertise can help you ensure that your electrical system is safe and compliant with all applicable codes and regulations. It's always better to be safe than sorry when it comes to electricity.